Hi, Scubrooter here. So my little power regulator thermostat unit that controls my little electric hot plate that I use for making meals stopped working. I did a quick voltage check on it, and it showed that it wasn't operational. So just to kind of prove it again, I'm going to do some tests. I'm also going to crack it open and see what's happening inside. See if there's not anything that I can replace or repair in there to get this unit back operating again, because I don't want to spend $30, $40 on a replacement one of these if it's just something simple. So first things first, I'm going to make sure it's in the off position and plug it into electricity. Now I know there's electricity here because I take this little kilowatt unit and I can see that there's 117 volts of electricity. So, switch on the dial. Now normally, if even if it's not plugged in, turning this dial on will cause this little indicator light to go red. It's not doing that. So, it's faulty, definitely failing. So let's turn it off. Let's unplug the electricity. And let's take a look inside. Now, this is a unit that uses 120 volt AC. So if you're not comfortable with that, get someone else to do it for you, and or spend the money and buy yourself a replacement. But I'm more of a fan of repairing something over throwing it in the garbage. So there's 4 screws on the bottom here. Just start by removing 4 of them. 1, 2, 3, 4, and let's see how easily it pulls apart. Well, that was really, really easy. Okay, so I'm just gonna do some assumptions here and take a look at how it goes. So looks like the green ground is most likely the center pin, and then I've got the left and right. I don't know which one's neutral and which one's positive, but what we can do is we can take our multimeter here and switch it to the ohm kind of continuity mode. And continuity is normally indicated by the little sound wave signals on most meters. So I'm just gonna, perfect, so we know that works. Okay, well, I can see that green wire going all the way to the bottom of the, and correct me if I'm wrong, I'm gonna say it's a rheostat, I don't know, some kind of dial that allows it to adjust to temperature. I'm pretty sure it's really a simple kind of system here, something like as the metal heats up, it flexes and loses continuity. But I'm going to put the negative, my probe on the negative pin, or the ground pin, and I'm just going to touch where the green wire goes for ground. So it beeped there, so that means that I know my connection from the ground to the wherever the ground is connected inside is good. Nothing's burnt out along the wire. I'm going to go from the one pin here and check. It doesn't go to that side. It doesn't go here either. This must be the side that's connected to the switch. So if I trace this back, the whole mechanism lives right here. And there's the contact. Well, it doesn't go there either. So my next thought is, well, let's check the other pin, because that first pin didn't make a noise. So let's try this one. Oh, okay, that one goes to this side. Nothing there. Now, granted, we turned the dial off, so I'm going to turn the dial back on. And let's see now if I can get it to show continuity on that other side. Okay, so that we know the circuit goes through the cord, goes through the brains of the matter, and comes out this side. So that is a circuit. So that still leaves the other side and that contact. So there's no continuity through there. We also know that this side doesn't actually go through the part inside. So let's just keep looking. We've got it here, and we have this sheath. I'm just going to bring this into the camera. We'll take a look at what's happening under this sheath. So it looks like there's some wires in there. Let's try to cut that back. Let's see if I've got a little knife that we can use on that. Okay. Now, because I want to keep this, I'm just going to make a small incision down the side of it and try and not cut anything. Also, try not to cut myself. And peel off this kind of cotton insulator. Oh. So there is an active component in here. We've got, I don't know exactly what that is, but let's test both sides of that connection. So we'll go here and we'll test the contact pin. Nothing. Test this side of this device, and then let's test the other side of that device. Oh. Okay. So I think I've isolated it to whatever this device is. Let's see if we put the probes on both sides. Nothing. So for sure it is whatever that little silver thing is. So let's do some more deducing. Make sure my camera focuses. There we go. Peel this out carefully, not to break anything. It doesn't want to come out. Let's see if I can just pull it out with a screwdriver. Oh, there we go. Got it to come loose. So that device, see if I can get it on camera so I can read it back later. Oh, there it does say something there. There we go. Locked it in. I'm just going to pull it off camera and see what I can't read. Micro temp. 117C. So I think that is a thermal fuse. So if that connection gets any hotter, then I'm going to assume the blow temperature on there is 117 degrees. Any hotter than 117 degrees, it's going to cause this to blow and, save your house from burning down. So what I'm going to do is I'm going to see if I can't remove this and order myself a new one. It looks like it's in there pretty good. So let's start with seeing if I have a replacement and see what I can't do about removing this from the circuit. Okay. So until next time, comment and ask questions below. And if anyone kind of has a better idea what's going on here, feel free to give me some direction. But I feel like if I can order a couple replacement thermal fuses, we should be good. Thank you for watching. Have a great day.